Hello world, it's Rahul. Welcome back guys to deep learning tutorial. So guys, today we are going to discuss basic intuition about attention mechanism. Before jumping to any definition, let me give you a real life scenario so that you will understand in better way. So guys, when you read a page in a book, the majority of what is in your field of vision is actually disregarded and you pay more attention to the word that you are currently reading. This allows your brain to only focus on what matters most or what you want to read while ignoring everything else. So I can say that attention mechanism is inspired by the human visual processing system. So by the same mean, in deep learning, we assign an attention weight to each of our inputs, and these weights represent the relative importance of each input element to the other input elements. This way, we guide our model to pay greater attention to particular inputs that are more critical for performing the task at the end. So guys, let's have a look at why and when this attention mechanism needs to be implemented in deep learning. So guys, attention mechanism was first used for machine translation, which was making use of sequence to sequence models, where we pass input sentence to RNN as you can see on the screen, and it functions as an encoder. So here I have denoted it with letter H and letter S for the decoder. So these hidden states can contain information from all the previous words in our sentence. Using this capability of hidden states, a context vector is constructed from the last hidden state in encoder side, which actually stores the content of the source sentence. Now, this is passed to decoder so that it can translate the words into the target language. But guys, one thing to note here is that there was one problem, and that was, what if sentence is long? All the information could not be compressed in the last hidden state, and due to that, our translation would be incorrect and inaccurate if the input sentence is long and detailed. So guys, to address this bottleneck problem that arises with the use of a fixed length encoding vector, where the decoder would have limited access to the information provided by the input. This is thought to become especially problematic for a long or complex sequences, where the dimensionality for their representation would be forced to be the same as for shorter or simple sequences. We use attention mechanism where we give context vector access to the entire input sequence instead of just the last hidden state. So in this way, even if the length of the sentence increases, the context vector can still contain the content of the sentence. So now, we just have to assign an attention weight on each of those inputs so that decoder can focus on the relevant positions in the input sequence. So guys, let's implement attention mechanism for sentence translation model with a simple example. Let's say we have an English sentence, Rahul is a good boy, and target sentence, Rahul एक अच्छा लड़का है. So before we start decoding, we first need to encode the input sentence into a set of internal states, let's say H1, H2, H3, H4 and H5. So guys, here we have to consider one hypothesis that the next word in the output sequence is dependent on the current state of the decoder as well as on the hidden state of the encoder. Since we are predicting the first word itself, the decoder does not have any current internal state. For this reason, we will consider the last state of the encoder, that is H5, as the previous decoder state. Now, using all the encoder states and the current state of the decoder, we will train a simple feed-forward neural network. Now, we don't need all the encoder states to predict the first word, that is Hindi translation of Rahul. But we need those encoder states which store informations about the word Rahul in the input sequence. So let's say word Rahul is present in the states H1 and H2. Thus, we want our decoder to pay more attention to the states H1 and H2 while paying less attention to the remaining states of the encoder. For this reason, we will train a feed-forward neural network which will learn to identify relevant encoder states by generating a high score for the states for which attention is to be paid while low score for the states which are to be ignored. Let S1, S2, S3, S4 and S5 be the scores generated for the states H1, H2, H3, H4 and H5 correspondingly. Since we assume that we need to pay more attention to the states H1 and H2 and ignore H3, H4 and H5 in order to predict Rahul, we expect the neural to generate scores such that S1 and S2 are high while S3, S4 and S5 are relatively low. So guys, just to let you know, we call these scores as alignment score, which indicates how well the elements of the input sequence align with the current output at position t by making use of a formula as shown on the screen. Once these scores are generated, we apply a softmax on these scores to produce the attention weights E1, E2, E3, E4 and E5 as shown on the screen. So guys, to know why I have used softmax function over here, you can watch my activation function video where I have explained about the softmax function. Now let's compute the context vector which will be used by the decoder in order to predict the next word in the sequence. So here is the formula for computing the context vector as you can see on the screen, and that is context vector is equal to E1 into H1 plus E2 into H2 plus E3 into H3 plus E4 into H4 plus E5 into H5. Now we will simply concatenate context vector and the output word generated from the previous timestamp and feed the merged vector to the decoder to generate the next word in the sequence. Guys, just to add one thing over here is that for the first timestamp, since there is no output from the previous timestamp, we use a special start token for this purpose. After all this processing, the decoder then generates the next word in the sequence, that is Rahul, and along with the output, the decoder will also generate an internal hidden state, and let's call it as D1. So guys, same thing, we have to iterate till we got the entire input translated. So now here D1 will be Rahul, and during the time of concatenation we will feed Rahul instead of start token, and we will get the output and hidden state D2 as Ek. In next iteration D2 will be Ek, and during the time of concatenation we will feed Ek instead of Rahul, and we will get the output and hidden state D3 as Acha. In next iteration we will get Ladka as an output and hidden state D4 by the same mean, and finally we will get Hai in the last iteration. But this is not it, as Hai will be assigned as hidden state D5 and same process will get repeated, but once the decoder outputs the end token, then we stop the generation process. So guys, this is all about attention mechanism. Hope you guys understand each segment of this video. Thank you guys for your time. Do like, share and subscribe. Hit the bell icon to get the latest updates. Happy learning and stay safe.